Hi there. So I made my picture a little bit bigger today because I noticed I was trying to show you things yesterday in yesterday's video and it wasn't really working because it was really small. So today is the second part of Explore. We're going to explore some more water today. All right, so hopefully you have your lab sheet. If you do not have your lab sheet done, you're going to have to do this with pictures. All right, so I was kind enough to do that for you, make some pictures so that you can still do the work. Ha ha ha. Just because you didn't turn in your lab sheet doesn't mean you get to sit and do nothing. You know better than that. You know better than that. Ha ha. Anyways, okay, so today is uneven distribution. We all know what that is. We've been talking about that for a very long time. So do your vocab first. Quick, do your National Roof Over Your Head Day. We should all be thankful for that you have a roof over your head because not everyone has that luxury. So be thankful for the roof that you have over your head. All right. So today we are going to do the water lab. So there are 3 parts of this water lab. You are going to, as a small group, you're going to visit each lab station and conduct an investigation, observing water in different states. You're going to record your observations in your science notebook, all right? And then you're going to use the discussion questions to help you predict how the molecules are behaving, and you have to draw diagrams. Okay, so we're drawing. That's one of the big things this time around. All right, so first thing, you're going to visit lab stations. If you are not appropriate in the lab, the teacher has the right to sit you down and make you do this without moving. You can do this lab without moving. You just have to look at the pictures, just like the ones that don't turn their lab safety sheet in. So it's not as much fun, I promise, but it can be done without moving around. So please behave. Please be respectful. And please don't break anything, okay? So what you're going to do is you're going to think about scale, proportion, and quantity. All right, that's our science factor for the day. We know from the pictures that we saw that water comes in many different forms. It comes in form of rain, snow, ice, even it's invisible in the air. So how do we know that water molecules behave differently in these different forms? How do we know? So we're going to actually be able to see that a little bit today. All right. And this is, you're really focusing on how do you think the water molecules, remember we made that starburst water molecule atom yesterday, and that's just a teeny tiny, that's just a scale model. There are actually in one glass of water, there's millions of water molecules in one glass of water. Okay, so there's lots and lots. All right, so how do those behave? And we're going to record your observations. That's what scientists do. So make sure you are working on that. And then think about cause and effect relationships to identify the experiment and predict how the molecules behave based on the factors that we put into place. All right, so this is in the slideshow. And I've actually created a lab slides and directions. All right, this is in page 20 in your notebook. If you did not turn in your lab safety sheet, you're going to use this slide. If you did and you still want to use the slides to kind of help you through it, that's fine too. It's not a big deal, okay? It's in both places. So in general, your station 1 is liquid water, hot and cold. So you're going to be in the back corner, left-hand corner of the room where the think outside the box sink is. Hopefully the janitor turned that sink back on. Do not behave badly with that one or it'll go right back off. Okay. So in that one, what you're going to do is you're going to have 2 beakers, same size of water. Okay. And then one is going to have cold water in it. And then one you need to put hot water in. Okay. So We may or may not have a burner back there just to warm up the water, depending on how you behave. Okay? Because the warm water is a commodity that we don't really get a whole lot of in this building, I guess. So there may be a burner back there. If there is a burner back there to warm up the water, please do not touch the coils. It will burn you. This is why you had to turn in the lab safety sheet. So that if you do something not very bright, it's not my fault. It's your fault because you knew better. Okay. So one glass is going to be on the burner or going to be warm water, hot water. The other glass is just going to come right out of the tap. It's going to be cold water. Okay. So what you're going to do in your experiment, and there could be two groups going at the same time, and that's fine. There should be enough containers for each. Okay. So do not put a plastic glass on the burner. Okay. Bad idea. So once you have your glasses, one has warm water, one has cold water, then you and your partner are going to take the food coloring, okay, food coloring, 1 drop in each at the same time. And then you're going to watch the water. You're going to watch the food coloring and see what happens. What happens with the warm water? What happens with the cold water? Write your observations down. Tell me what happens. Okay, so that's what you're going to do on this one. You're drawing a diagram. What did it look like? Drawing a diagram. What did it look like? Okay. The second station is gaseous water. Hopefully the guest teacher will place themselves here because this one is a little bit messy. All right, you're going to have, on this one, you're going to have a flask. This is a flask. Okay. You will need tongs, all right, because this is going to be boiling water. It's going to be very, very hot water, okay, because we have to make a gaseous liquid, which requires a lot of heat. So this is going to be on a burner as well. I don't really want you guys messing with this. The teacher's going to have to add water because what happens when water boils? Becomes gaseous and it evaporates, okay? So we're going to have to keep adding water to this. So do not do that. All right, so you're going to take the tongs. These are the tongs. You're going to squeeze here, and what that does is that opens that up, okay? If you're a girl and you do eyelashes, it's like that. It's an eyelash curler, right? But this one, you're going to put your flask in there. And that'll keep your hands away from the heat, from the boiling water, okay? Let me make it bigger so you can see me. Okay. Okay, so tongs, keep your hands away from the heat. What you're going to do is you're going to take your flask and you're going to flip the glass. Now, you might have to do it depending on how deep the glass is, okay? This is going to have, another container is going to have a bubble solution. Okay? So just soap, right? Soap doesn't taste good, so don't eat it. So you're going to dip your soap bubble in the solution so that the bottom of it is got liquid on it, got the bubbles on it, okay? Then what you're going to do is put this in the bubbling water. Just leave it like that. Okay, that's going to be having bubbling, boiling water. And then you need to watch the top. Watch the top, watch the top, watch the top. See what happens. Then you're going to draw a picture. Flash pushed into hot water. Okay? So you're pushing the flask into the hot water. Then you're going to watch and see what happens. All right, now, then you're going to take the flask out and put it in cold water. Watch. Watch the top and see what happens. Okay, and then make a description. All right, that's what you're doing on that one. The third one is ice. The third one is it's going to be on the right-hand side of the room, or the one by the CER wall. And you're going to have, hopefully, and you're going to be patient while the teacher goes and grabs the ice cube tray. So you're going to have a blue ice cube tray. Grab it. Okay. Your ice cube tray. The teacher is going to, hopefully the night before, remember to put in ice cubes in a couple of different variety of places. Okay. And then what you're going to do is you're going to put 2 tablespoons, because the teacher's going to use 2 tablespoons of water and freeze it overnight. And then you're going to put 2 tablespoons of water next to that, and then you're going to compare. Are they different at all? How are they different? Draw a picture of the two. Explain to me, how are they different? Okay, what's the difference between the two? Okay. So, with that said, we're going to go back here to the slides. I'm going to show you the slides. If you mess around and you don't get it done, this is not going to extend into another day. If you're not behaving appropriately, you're going to finish it with the slideshow. Okay. So if you are behaving inappropriately, the teacher has the right to sit you down and make you do it this way. Okay. So remember that we have a facilitator, materials manager, harmonizer, and a recorder. All right. You're going to diagram the experiment, record your observations, and draw a model. Okay, how is the water molecules, your model, how are the water molecules behaving? That's what your picture should show. Okay, what do you think the water molecules are behaving? And I have a couple of, if you're watching the video and you're looking at this slide, there are some cheat codes in this slideshow for you to help you with that. So this is experiment 1. Just a reminder, these are the things that you need. This is a video of the actual experiment that I found online. So if you're not doing it physically, then you can watch the video and still answer the questions and still draw the picture. Okay? So no excuses. Here's the gaseous water. Here's the directions. These are the supplies you need. And then this is my pictures from last year's group on how they did it and what it looks like. Okay. So here's a trick. If you look at that, that is what in the hot water. If you take it out of the hot water before that pops and put it in the cold water, something cool might happen. I'm not going to tell you what, because I want you to try it. All right, think about it. And then solid ice. So here are what you need for that. And then I did this at home. For those of you who don't have your lab safety sheets in, I could only use 1 tablespoon because my ice trays are smaller than this. So if you can see, this is just liquid water. And then this is comparing ice, and 1 tablespoon of water, 1 tablespoon of ice. All right, and then here's your cheat sheet for what the water molecules are doing differently. Okay, there's your cheat code for that. Also, pretty cool time-lapse video of water freezing. That might be a little bit of a secret for a gradable activity that we're going to do in a couple of days. So this is a really cool video that might help you with that as evidence. And then here are the cheat codes that I was talking to you about. This is what those water molecules are doing. In hot water, remember about the Bill Nye video, the hot water is making your water molecules go crazy, bouncing around. And then the liquid, just the regular warm water or regular water, the liquid is just kind of chilling. And the solid, the ice is kind of just stuck together. Okay, so when those do what they got to do, the water molecules respond. So ice, the reason ice takes up more room is because it spreads out, okay? Water by itself is just kind of chilling, just filling the container. And when it freezes, okay, they spread out, all right? And when they heat up, they bounce around like they've just had a bunch of sugar, okay? So think about the 3 forms of water. All right. So that is that. Have fun with that, and there are more videos to come for next week's lessons. All right. Hope you had a good time and enjoyed that.